Serious math, serious fun. Patterns found in digit sums of multiples from 9 to 1. Want to play math? Help me define attributes of some designs created by digit sums of multiples from 9 to 1. Well, what should our first step be? Begin with multiples of 3. Now let's find digit sums of the multiples of number 3. How do we find digit sums? Add digits from the hundreds, tens, and ones until the sum total's shown and a single digit stands alone. With sums in hand, go dot to dot. Wow, who would have thought? Do you think the other digit sums will plot this same design or not? What patterns do you see in multiples of 6 and 3? The pattern made by digit sums of multiples of 3 become a triangle. 6 made one too. What will the other numbers do? Both of these shapes are circling an imaginary central string called an axis, or many axes, showing mirror symmetry, which means that both halves will cover and are reflections of each other, and they can be folded down the middle thrice. 3 times is always thrice as nice. Will number pairs that add to 9 always make the same design? Will each of them make triangles? Could there be some quadrangles? Or pentangles? Or septangles? Right angles? Or just plain tangles? Try more number pairs. This game's not done. This time, look at 8 and 1. This pattern's not at all the same as that of 6 and 3. Great game! How many sides have these shapes got? 9 in total? That's a lot. That's why it's called a nonagon. The name tells us how it was drawn. Flip them over, they look the same. Can we give that property a name? This trait is, in reality, known as achirality. Achirality is when, in your mirror, you see a twin, and when shapes look the same, front or back. What shape will 2 and 7 track? Two's pattern was created the same direction clocks rotate in. 7 spirals the other way, which is counterclockwise, shall we say. Do pairs make patterns of their own, unique to them, and theirs alone? So far, patterns found look like each other, yet aren't the same as any other. Ready? Okay, let's take a dive in digit sums of 4 and 5. Now let's watch 4 and 5 as they begin to shine, just like stars that spin. These 9-pointed stars seem to show the same design as round they go. In fact, this twirly property is rotational symmetry. Use an outline as a guide, then count the times they fit inside as the star spins and turns, then to the start, the star returns. What pairs are left? 9 and null. I guess guess we should try them all. There isn't any place to go. The circle's blank, of course. Hello. That multiples of 0 show no lines, I understand. But oh, how will multiples of 9 imitate that same design? No way. So every single time we multiply by number 9, the digit sums are all the same? You mean that every single one amounts to the exact same sum, which also is the multiplier? Exactly how did this transpire? Okay, back to play. How come these patterns are nonagons, triangles, suns, and stars? What other mysteries lie behind the digit sums that shake our minds? These designs from multiples of number pairs that add to 9? Once upon a time, a circle was, outlined in dots, from 1 to 9. Then we made plots of digit sums from the times tables in base 10, which then enabled us to see patterns, axes, symmetry, clockwise chirality, counterclockwise number lines, qualities of like designs, together living affably, forever after, happily. This game's been fun, but now we're through. Next time, could I play math with you?